we are live. This is Math 40, section 1.2. This is all about everyone's favorite subject, topic, fractions. Woohoo! And yes, I'm being completely silly about that. I know most people are not really fond of fractions. Most people really would rather do decimals. It turns out the bad news is that fractions are really, really important in math, especially, and you're going to hear me say this again, especially those of you who want to go on and take calculus, which I hope all of you consider, even if you may decide not to, because calculus is just so fundamental for a lot of different fields, for all the sciences, for business, for law, for architecture. So there are a lot of wonderful things you can do with calculus. But first, we got to talk about fractions. Now, having said that, this is just going to be the introductory section for fractions. There will be a lot of other fraction chapters, or there will be a fraction chapter, or two fraction chapters after this. So if this doesn't quite explain them to you, that's okay. We're going to come back around and cover it again. So we'll keep going over it. Hopefully we'll make you feel really comfortable about fractions. You might never like them, but hopefully you will understand them. So we're going to start off with not fractions, but factors. So what are the factors of 6? Now here's one of those super fun vocabulary words where people are like, factors, which ones are factors? Factors are the smaller pieces. They're the pieces of. So what numbers, in other words, what numbers go into 6? So a lot of people, if we were in class together, someone would shout out 2, and I'd say yes. And they'd say 3, and I'd say yes. And then they'd say, that's it. And then I'd say yes. But mathematicians tend to like the technical. One might call them the trivial answers. So what other numbers go into 6? And maybe you got it. 1 and 6 itself. There are actually 4 factors of 6. 1, 2, 3, and 6 all go into 6. I know, and some people look at 6 and they're like, it only goes in once. And the answer is yes, but it is a factor. So what are some multiples of 6? Now, this is a slightly different word, and this word tends to get confused with factors. Multiples is like multiplication. We're multiplying times 6. So multiples of 6 would be 6, 12, 18, 24. Now, can I write down all the multiples of 6? No. So what I'm going to do is I'm going to do a ... That's called ellipses, is the name for that. And sorry, I was giving the I love you sign, or I was throwing down for some heavy metal over here. I can't help it. Too many heavy metal concerts. So 6, 12, 18, 24, and it just keeps going. You could go on. You could say 600. You could say 6,000. You could say 6 million. So how many multiples are there? A whole bunch. So the trick here is to remember factors are smaller and they're limited. Multiples are bigger, unlimited. So next up, prime numbers. A number which is only divisible by 1 and itself. So a lot of people think of 2 first. That's a great one. 3 is a good one. Is 4 a prime number? And the answer is no. 4 is not prime because it is 2 times 2. So you can break it down into a product of 2 other numbers, so it's not prime. 2 is prime because nothing goes into it. 3 is prime. In terms of bigger primes, maybe 11, 13. You can think of some others, and we're going to do that on the next page. So basically, there are no other factors other than 1 in itself. Nothing else goes into it. Now, what about 1? it doesn't count. And it doesn't count because of a technicality. And I don't know, when I've tried to tell people about the technicality, their eyes kind of glaze over and they're really sorry they asked. So be ready to fast forward. But basically, when we talk about prime numbers, we want to talk about factoring into prime numbers. For example, back up here with 6, I could say 6 equals 2 times 3. They're both primes. If I include 1 as a prime number, the problem is how many times does 1 go into something? Well, you could multiply 1 times something. You do 1 times 1 times 1 times 1 and say that 100 times and you still have just 1. So the difficulty there is when we start to talk about ones, they don't build to anything bigger, so it makes it difficult to deal with. So we actually qualify 1 counts as something else entirely. It has to do, it's a fun phrase called the multiplicative identity. We'll get to that later. But it doesn't count as a prime. And I know a lot of people are like, hey, that's not fair. And the answer is, again, people worked out the rules a couple hundred years ago for a lot of these things, and they've worked pretty well so far. So this is the math. Now, if you want to come up with your own branch of mathematics and do some research and create some new definitions, you go for it. But this is the definition we got. A composite number usually is just all the other numbers. A number which has factors other than 1 in itself. So would 2 count? No, of course not, because it's prime. How about 4? Yeah, 4. 5? No, 5 is prime. How about 12? Yep, 12. And if I ask you, is it composite? You should be able to say, sorry about the whistle, 2 times 2 or 3 times 4. So basically, if you can break this into smaller pieces, and when I say that, I'm thinking about Legos, when you're breaking Legos, like if you've got Legos stuck together, if you can break the piece that you've built into smaller, pull apart the Legos, then that was a composite. If you've got a big Lego that's just a single piece, that's prime. Okay, so we got prime and composite. And so here, we've got the prime numbers between 1 and 100. And I think the instructions, oh no, I'm missing a page. I'm missing a page in my notes. And that's very exciting, isn't it? Okay, well, I will tell you what's happening in the prime numbers between 1 and 100. This list has some errors. Because you're going to notice that in this list, I've got all the numbers written out between 1 and 100. So let's find the prime numbers. First off, 1 doesn't count, so I'm going to cross that out. 2 and 3, yep. Now here things get a little exciting. Now if we were in class together, everyone would be working on this together. Everyone would be sitting there with their calculators. So, definitely have your calculator out and be checking like what numbers are divisible by other numbers. 4. Now 4 is 2 times 2, so that doesn't count. But I do want to point out that if you look down, 14 is 2 times 7. 24 is 2 times 12. 34, 2 goes into that, 2 goes into this. If you look down this whole aisle, this whole column, these are composite numbers because 2 goes into them. Because look here, 5 is prime, but look down, 15, 25, 35, 45. Hopefully you're recognizing, wait, 15, 5 goes into that. 25, 5 goes into that, goes into that. Okay, so we can cross these guys all off. 5 goes into all of these. That makes them all composite. Then 6 is 6 prime? No, 2 times 3. And again, this one's 2 times 2, this one's 2 times 3, so it doesn't count. And let's look down this aisle, or this column. Every number here ends in a 6, which means this is 2 times 8, this is 2 times 13, this is 2 times 18. Each of these is divisible by 2, so we can cross all of these guys off too. Okay, so we're getting, this is interesting. 7 is definitely prime. These are hard, so I'm going to skip them for right now. 8, 2 times 4, not prime. And all of these, not prime, 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 not prime. Okay, 9. Now, people are like, 3, no, yes, no, yes, no, yes. And people are ready to say yes for 9. Is 9 prime? Nope. It's sneaky. It's odd, but it's 3 times 3. So it doesn't count. This column is hard, so I'm going to leave it. 10, 2 times 5. Now look at all these guys. 20, 30, 40, 50, 60. 10 goes into each of these, so none of these are prime. All right, we're trying to figure out which ones break down into smaller pieces. Oh, I skipped an aisle. The 2s. 12, 22, 32, 42, 52, 62, 72, 82, 92. You got it. See, this is one of the problems with not being in class, is you guys can't just yell out, you missed one, that column. Okay, so we've taken out more than half of the numbers. So you can already tell the prime numbers are actually, most numbers, it seems, are not in fact primes. So primes can be kind of tricksy to find. So now we're going to go through. This is usually best done either with a friend or with the help of our friend Google. 11, yes, is prime. 13, yes, it's prime. 15, nope. 17, yep. 19, yep. 21, I know you want to say yes, but is it? 3 times 7, so nope. 23, yep. 27, sneaky one, so sneaky. 27 is 3 times 9. Now, this is a great opportunity for me to advertise that if you do not already have one, if you can get your hands on some index cards. And the problem is you don't want to do it with like a pen that's like leaves a big impression, but maybe something like on one side you would write 3 times 9. And on the other side you would write 27. Obviously, my cat is very excited about learning his multiplication tables. He's very excited about that, right? So then you could be, say, on, well, a lot of you are not on the bus as much, but if you do find yourself with some downtime, or maybe you're at a party and everyone's like, oh, we're so bored, what can we do? And you could be like, hey, let's practice our multiplication tables. And then everyone at the party would be like, oh, wow, you're the coolest one ever. And you would be like, I know, I'm so cool. I'm studying math. It's totally the way it would work. So 3 times 9, I've been told, I haven't been to a lot of parties, but I've been told that totally happens. 3 times 9 is what? 27. So you can test yourself. And then when you've got this set of lovely, practice cards, when you've got them all nailed down, then you hand them to another person, perhaps even a younger person in your family, and you help them learn their times tables. You see how we do this? Eventually the whole world will know math. Wahahaha. Okay. So back to here. So now at this point, if I were you, I'd be a little nervous. Be like, ooh, I don't know. 29 is. 31? Yep. 33? Oh, sneaky. 11 goes into 33. Now, here's the thing about patterns. Hopefully, throughout this class, I start to introduce you to some interesting patterns and you start to get to know them and like them. There is a pattern that comes across here: 11, 22, 33, 44, 55, 66, 77, 88, 99. All of these coming through here These are all divisible. Divisible by 11. So they're all crossed off. Okay. Let's see, the 30s. There aren't a lot of 30s. 37, yes. 39. Oh, it's so sneaky. It's 3 times 13. Oh. 41. Yes, 41 is prime. 43. 47. It's one of the sneaky ones where it's like, oh, I don't know. It is. And then 49. And usually, I'm like, yes, that's prime. It's not prime. What goes into 49? You got it. 7 times 7. And so the question is, a lot of people ask, they're like, well, I've got my calculator. Do I need to know this? And the answer is, well, the more you can do in your head, the faster you will be at math, the more comfortable math will be. So you get to decide for yourself, how much of this do you want to store in your calculator? How much of this do you want to store in your head? And it really is, you've got to make that decision. I would say knowing your times tables, knowing your prime table, it's going to make your life so much easier, especially with fractions. So, anything that makes fractions easier is probably good way to spend your time. Plus, all of your friends will think you're cool. Okay, now the bane of my existence. So I got to tell you, when I am elected king, which I plan to be any minute now, 51 will be prime. However, it is not. 51 is actually 3 times 17. And I hate it. I think it's the meanest, trickiest one. Ugh. 53? Yep. 57? No. 57. Why you have to be like this, I don't know. Why do these numbers have to be? 57 is 3 times 19. When I am king, no one's going to multiply 3 times 19. That's just wrong. This is so wrong. Okay, 59. Yep. 61. Yep. 63. Sneaky. 3 goes into 63. 3 times 21. 67. Yep. 69. Nope. 3 times 23. Ugh. 71. Yep. 73. Yep. 79. Yep. So it's kind of interesting. I'm fascinated when I look, there are 4 in this row. There are only 2 here, 2 here, 3 here, 2 here, 2 here, 3 here. So there's some interesting patterns going on. 81, sneaky, 9 times 9, so nope. 83, yep. 87. So annoying. 87 is 3 times 29. Oh my goodness. Like the things that I'm going to make that illegal when I'm king. 89. Yep. 91. Let me pull up my calculator because 91 makes me very frustrated. 91 divided by 7 is 13. Who even thinks of these things? I know. 91, not prime. 93, it's 3 times 31. 97. At this point, if I were you, I'd be like, oh, I don't trust it. It is actually prime. So there we go. Those are all of our primes. Now, throughout the class, I make these because they make me happy. You don't need to care. I'm going to double check. I wrote this down earlier just to make sure I didn't mess any of them up. 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 67, 71, 73, 79, 83, 89, 97. And one thing that will be less obvious if you're not in classroom with me is that I have dyslexia. It is not severe. I've been very lucky, but I make a lot of mistakes. And so one of the things I do is I always double check. And the other thing I'm going to do is throughout the class, I'm going to make these little cards and then I'll scan them all. So if you're at all interested in them, you'll have a set of them if you would like to scan or print them out or just have them to look at. The things that I think are especially important, and a list of prime numbers less than 100, I find very useful. Okay, so we've got the primes. So now with that, and I apologize, this video has gone a little bit long. We're at 20 minutes, but we're going to do one problem and then call it a night for this video. And that is that this is something we're going to be doing a lot of. And this is called setting up a factor tree so we can express 1240 or 1240 as the product of primes. So 1240. I'm going to go ahead. And so what you have to do is you have to think, what is 1240? What goes into it? The first thing I notice is it ends with a 0. If it ends with a 0, it's 10 times, and then whatever's left, 10 times 124. And then 10, I find easy. It's 2 times 5. That one I just have memorized. Now, 2 and 5 are both primes, so I'm going to circle them. You don't have to. You could highlight them. You could just skip it. But basically, it means I'm done with this chain. Now I'm going to follow this chain. Now, 124, I don't have that one memorized, but I do notice that it's even. And because it's even, I'm going to say it's got to be 2 times something. Now, you can either do this in your head, or you do 124 divided by 2 is 62. And since 2 is a prime, I'll circle that little node. And then I've got 62. I can see that 2 is going to go into that. And again, I could just divide by 2 right there. 31. Check here. 31 is a prime. So 1240 is written as, now I could write it in the order I found them, but what you're going to see me do is I'm going to try to write them in descending order. And this was something I taught myself to do in school because, again, I have trouble with the order of things and forgetting things. So what I'm going to do is I'm looking through these, and 31 was the biggest one. So I wrote it down, and then I made a little dot there to tell me that one's done. Now, why not scratch it out? Well, if you scratch it out, then the teacher can't see your work. So it's hard to get partial credit on a problem you're writing out. So I just did a little dot. And I got 5, and I got 2, 2, 2. And in my double check, I'm going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. I've written this out as the product of primes. Woohoo! You guys are awesome. So this was the first part of 1.2. 1.2 is very long, so there'll be probably a couple more videos, and then we'll finish with it and get on to 1.3. Woohoo! Math on! You guys are awesome. Yay!